Some of you may have been wondering why we can treat dy dx as a fraction, and really we can't. We're not supposed to do that, but it ends up working out anyway because of some other stuff. So this video is on why separable equations, why does it work? And so the first thing is an ODE is separable if it can be written as h of y times y prime equals g of x. So h of y is some function, it only has y's in it. The y, h of y times y prime. So this h of y doesn't have any y primes in it, just y. And h of y is being multiplied by y prime. Then on the other side of the equation, you just have some function g of x. So what really ends up happening, and you have to keep in mind here, we actually integrate with respect to x on both sides underneath it all. So this is h of y prime dx equals indefinite integral g of x dx. Right, so indefinite integral on both sides, dx on both sides. And we're going to say here the antiderivative, antiderivative of h of y is capital H of y. And same thing, the antiderivative of our g of x is going to be capital G of x. So what ends up happening here is we have this h of y, and we also, to emphasize here, this isn't just h of y, it's h of y of x. Y is a function of x. And then that's multiplying y prime of x dx. And on this other side, we have the indefinite integral of g of x dx. So now here, if the antiderivative of lowercase h of y is capital H of y, and the antiderivative of lowercase g of x equals capital G of x, then over here, what ends up happening is this ends up just simplifying to h, capital H of y. And over here, this ends up simplifying to capital G of x and the plus c. So that's a little strange, where did the y prime go? And it's really implicit differentiation. So if I go over here and I actually do, what is d dx of capital H of y? And really, to be explicit, that's d dx of capital H of y of x. And so what we'll have to do here is a chain rule. And so we have d dx of h of y of x. Well, we're taking the derivative of h, that is a capital H, that ends up being lowercase h of y of x. All right, then the chain rule is we're going to have the derivative of the interior function multiplying on the outside. So we're going to have times y of x prime. And that simplifies to h of y of x times y prime of x. And if we drop all the x's, it's just h of y prime. And so the reason that this step works is because of the chain rule. We're essentially absorbing the y prime of x when we're integrating with respect to x here on this lowercase h. And so it just becomes capital H of y of x, and that y prime got absorbed during the integration. But it turns out, even though we're not supposed to treat dy dx as a fraction, and you can also do a u substitution, I think, to get this to happen, you could also just say, well, okay, it's the same thing. We get the same answer if we pretend we're doing h of y times dy equals indefinite integral g of x, lowercase g of x, times dx. It ends up giving you the same answer. We have capital H of y equals capital G of x plus c. All right, so really this thing where we split up the y prime into dy dx and we treat it like a fraction, and we end up with, dy on one side of the indefinite integral of dy on one side and indefinite integral of dx on the other side, it ends up working, even though we're really not supposed to do that. And the reason that happens is because of the chain rule, and that y prime will actually get absorbed into the h of y during the integration. All right, so for those of you who are wondering why this works, in the future you should be very careful and never rely on being able to split up dy dx like a fraction, but it just notationally it's very convenient for separable equations to do that because at the end of the day it all ends up working out anyway.